L.1.7, what's our learning goal today? What does it say over there we're going to learn? What should you be able to do, Justin?
I can solve equations in one variable that contains absolute value expression.
Okay, I can solve equations. Do you know what equations are?
Yes.
What are they?
Numbers.
Do they or don't they have an equal sign?
They do.
They do. So we have an algebraic, or it could be algebraic, it could be numerical. We have an expression on one side set equal to another expression. That's an equation, right? Okay. One variable. We know what variables are, correct? Have we been solving equations in one variable so far? Solving for x, solving for a, solving, except for this last lesson when we've been solving literal equations. Up until this last lesson, we always just had one variable in our equations that we solved for. Okay. What we haven't had in them yet is something called an absolute value expression. We know what an expression is, though, right? What doesn't an expression have? An equal sign. An expression does not have an equal sign. It can have what? Letters. It can have variables. It can have numbers, which we call constants, and it can have so operations, yeah, so like addition, subtraction, we can have operations. We learned that that's what expressions can be made up of. Constants, variables, operations. Well, now we're talking about absolute value expressions. Does anybody happen to know what the symbol is that tells you it's an absolute value expression? Have you ever seen it, heard of it before? Have any idea what an absolute value expression is? Okay, let me show you. You see these guys like this. You see some vertical line segments. You see some vertical line segments on either side of an algebraic or a numerical expression. You have yourself an absolute value expression. Now, notice they're not going to be, I didn't say curved, I didn't say curly cute, I didn't say anything about there being a top and a bottom. I said vertical line segments, just like this, okay? When you see those, you have what's called an absolute value. Absolute value. So, we're going to be working with absolute value. Let's start with just solving this problem here. Without any, we just can find a way to do it. In a game show, we have two contestants. They guess the price of the DVD player. They each make a different guess, and both are off exactly $15. If the actual price is $169, what were their guesses? Go ahead and fill in those blanks. Go ahead, figure out what was each contestant's guess if both of them were off exactly $15, but yet they made different guesses. So Russell, what's one of them?
154.
Okay, one of them guessed $154. How did you get that, Russell?
I took 160, subtract 50.
You took 169 and you subtracted 15. You said going away from it to the left. In other words, the guy that guessed too low guessed $154. Nick?
The other one was 184.
Okay, and how'd you get that one, Nick?
I added 15 to the actual answer.
Okay, so then you added 15 to the 169, and that guy or gal, guessed $15 too much, but they both guessed exactly $15 away from the actual price. Okay. Anybody have a different one they want to convince us of? Okay. Well, we can represent that situation with the equation because you know how I am. I say we can pretty much do everything we want with algebra. We can write an algebraic equation for just about everything. Okay. So we can represent that situation with this equation. X, take away 169 in between those vertical line, those vertical line segments that I said we're going to call what? Absolute value. This means absolute value. So we have the absolute value of X, take away 169. That is supposed to equal 15. I'm telling you that represents that situation up there. So that is read as what numbers are, see this number over here? The number that you all worked with, you took 15 away and then you added 15? That's what we call the distance. So 15 units of distance from 169, yeah, from 169. I've been saying that wrong all day. 15 units of distance from 169. I'll correct that in my other classes tomorrow. Okay, so absolute value represents, anybody know what the actual definition of absolute value is? What is it?
Has no value.
No, absolute value has value. Anybody have any idea what absolute value is? Because it does have value. Marco, you want to make another wild guess here?
It has very little value.
It has very little value. It can have lots of value actually too. Justin?
It always has value?
Yeah. Well, you can say that it most of the time has value. Okay, here's what absolute value is. Distance. You guys should have heard about absolute value before you got to 9th grade, but apparently we haven't. Absolute value represents distance from 0. How far away is that from 0, that number? When you were asking for the absolute value of something, you're asking for how far is it away from 0? Okay, so I say if it's distance from 0, then therefore any non-zero, so I'm talking about when we say non-zero, we can talk about the negative numbers on the number line, we can talk about the positive numbers on the number line, we just can't include 0. Any non-zero number, the absolute value of it, there are how many numbers that would have the same absolute value, the same distance from 0? How many numbers on the number line, if they're not 0, would have the same distance from 0? 2. 2 numbers that have the same absolute value. What do you suppose is 0's absolute value? 0. Is there another number that has an absolute value of 0, do you think? No. So any non-zero number, so in other words, if we said, what number could we put in here for x? That if we took its absolute value, or we asked somebody how far away is it from 0, they would answer us 10. So we have negative 10. Is negative 10 10 units away from 0? Okay. How about positive 10? Is it 10 units away from 0?
Yes.
Are there any other numbers on the number line 10 units away from 0?
No.
No. Those are the only 2. Okay, well then, let's figure out how we could solve an absolute value equation. Because I just said earlier, this equation right here can represent that game show thing, that we've got those 2 answers, 154 and 184. Well, if I told you to solve this algebraic equation, how would you go about it? So I've kind of narrowed it down to 3 steps, that if you follow these 3 steps when you're solving absolute value equations, hopefully you will eventually get to be successful at it, because they are confusing. Okay? First thing you're always going to look for is step A. Do I need to isolate the absolute value expression? In other words, is the absolute value expression by itself already on one side? That's the first thing you're always going to look for. What does isolate mean? Like, by itself. Is anything else going on with it?
No.
If you're isolated, can you have any buddies around? No. If you're in isolation, nobody else should be there, nothing should be there. So you need to, isolate means by itself. Okay, let's look at our equation. Do we need to do step A? Do we need to isolate the absolute value expression?
Yes.
Yes.
Okay, what do we need to do to isolate it then?
We need to get
We need the 169 out of there?
yeah.
Is the 169 outside the absolute value bars?
Oh, well,
No, it's inside of it. We want to isolate the absolute value expression. Absolute value, I don't care what's inside of it, that's part of the absolute value expression. Is there anything going on outside of the absolute value expression on the left side of the equation?
15.
No, we can skip step A. It is already by itself. It's not being multiplied by anything, it's not being divided by anything, there's nothing being added outside the absolute value bars, there's nothing being subtracted. It's already isolated. Okay? So we get to skip step A, skip A. We don't have to do it, it's already isolated, okay? Skip that step. Move on to step B where it says, to eliminate the absolute value bars, in other words, we need to get them out of there. Hear me on this, absolute value bars are not grouping symbols. We cannot do distributive property and treat them like parentheses. We never treat absolute value bars like parentheses. They are their own, one of a kind. They belong in their own category. They don't get to be called a grouping symbol. So we need to eliminate them, and we can't eliminate them by just dropping them. We have to follow a procedure. It says to eliminate them, rewrite the equation as two cases. Because remember what we said, this really says what numbers are 15 units away of distance from 169. Well, let's just think of it this way right now. What two numbers have a distance of 15? 15 and
Negative 15.
negative 15. So here's what we're going to do. We're going to ditch those absolute value bars. In step B, they go away. And we set what's inside the absolute value bars equal to any number that has the distance of that number on the other side. So x take away 169 can be set equal to 15, because 15 has a distance of 15. And x take away 169, that expression does not change, it stays there like it was, can be set equal to the other number that has a distance of 15. What's that?
Negative 15.
Negative 15. So when we eliminate those absolute value bars, we're saying, you know what? I'm going to set this equal to any number that has that distance. Are those the only two? Okay, then now we're ready to move on to step C. Step C says, solve both equations. Go ahead and solve those. You already know how. You don't need me to talk you through it. At least I hope we don't. And what did we get for solutions? Same solution we got up above before we set up an equation for this. And we get the same two answers. But now we know how to solve it as an absolute value equation. Okay, so there are two solutions. Typically we've been getting how many solutions? One, we've been solving equations and getting one solution. But with absolute value, we can get more than one solution. We can get two. And typically, we do get two. Okay, anybody have questions about anything there so far before we move on? Okay, let me tell you what students tend to do. That I'm not going to let you do it even right away from the beginning. I'll be like, no, don't do this. I'm going to take out points on an assessment for it. If in step B, those absolute value bars are still there, when you're doing your work, when you're starting to add, subtract, multiply, divide, whatever you need to do in step B, and those absolute value bars are still there, or in other words, if here you just left those absolute value bars and you were working with it like that, I'd have to take out some credit there and say your work is wrong. Because tell me something about distance. How do we measure distance? Justin? In feet, or inches, or centimeters, or miles, or... And do we say, okay, so, I decide tonight that, I'm not going to go from school until about midnight, and I'm parked out here, and I live over there, so I decide, I think there's nobody around. It's pretty quiet around here, I don't see anybody. I think I'll just back up and go around the corner, and then I'll head home. So when I back up, did I just back up a negative half a block? Or did I just back up a negative, 150 yards? Is that what I say? Do I say I covered a negative 150 yards?
No, you
Well, maybe use feet even, okay, so you wanna use feet. Do I say I want a negative 400 feet, 450 feet, whatever? Do we ever talk about distance as negative in other words? No, we don't. If we back up, we don't say, we went a negative amount of inches, feet, miles, whatever it is measured in. So here's what this says. Look what this says. This says we have distance. Absolute value means distance, remember? We have distance that's positive. Is that okay? That's actually okay, but is this okay? We have distance that's negative. Is there such a thing? No, we're not going to talk about distance being negative. So I'm going to tell you right now, I'm just going to right away from the beginning, I'm going to be really fussy about those absolute value bars not being in there in step B because step B eliminates them. We get rid of them. Okay? Okay, let's go to the back and solve some of these. Some more of them. Number 1. Somebody want to read to me how that equation reads? Nick?
Absolute value of x equals 6.
That's right, that's exactly what it says. The absolute value of x equals 6. Another way to say that would be the distance of x has to be 6. Okay, so, do we need to do step A?
No.
Step A says isolate the absolute value expression. Okay, so we get to skip step A. Okay, in our notes, let's just put that we skipped part A. We didn't have to do that. You're always going to have to do step B. You're always going to have to do step B. That's where you ditch the absolute value bars, you set up your cases. So what would our cases be for this one? Russell?
X equals 6 and x equals -6.
X equals 6 and x equals -6, the two numbers that have a distance of 6. Okay? Now we move on to step C, solve. Ready to solve here? No, in reality, step B and step C are kind of in the same one here. We would circle these and say there's our solutions. These are our solutions. Because there wasn't anything we had to do to isolate x. It was already isolated. Okay, let's look at number 2. Step A, isolate the absolute value expression. We need to skip step A this time?
No.
No. Okay, what is, how would we read that one? How would this one read? How would that equation? How would we say that one? Russell?
4 times absolute value of x equals 36.
Yeah, 4 times the absolute value of x equals 36. Remember those are parentheses though. So can we just drop them? And put a multiplication symbol in there instead? No. So you guys decided we did need to do step A? What are we going to do then? All right, Kara? Divide by 4. Why do we divide by 4? Because I agree, by the way, but why?
Because we multiplied by the absolute value.
Because the 4 is outside the absolute value bars, isn't it? Yeah, it's not part of the absolute value expression. So that's why we have to, so we're going to actually do step A, which says, you know what, you better divide and get that 4 out of there before you move on to step B. So we say, okay, well then it becomes the absolute value of x equals what?
Equals
Everybody, you can do this together.
9.
9, yeah. Okay. Okay. Now, don't just think that sometimes this is going to be a one-step process. You still have to ask yourself this question. Is the absolute value expression now isolated?
Yeah.
There's nothing else happening on that side with it. Okay. So now we move on to step B, where we set up our cases. What are our cases this time? Marco?
It would be x equals 9 and x equals -9.
Okay, the two numbers that have a distance of 9 are set equal to our expression that was inside the absolute value bars that we're now taking out of there. We're releasing it from it. We're getting rid of those absolute value bars. Do we need to do step C?
No.
Because x is already isolated. So here's our solutions again. Okay, why don't you go ahead and try number 3 on your own, or at least get a start to it. Do I need to isolate the absolute value expression? That would be your first question. Okay, so do we need to do step A?
Yes.
Okay, so what do we need to do step A? Nick?
I'll subtract 2 from both sides.
Subtract 2 from both sides. Okay, so hopefully that's what you guys are doing. You've been, that's your first rule here?
Yes.
Okay, so now it reads the absolute value of 3x is equal to 6, okay? Is the absolute value expression isolated now? Yes, okay, London? Yep, so we're moving on to B, aren't we? Okay, so in step B, we do what? What will it be, London?
Take out
This thing's called what?
absolute
Take out those absolute value bars and set up what's your cases?
3x equals 6 and 3x equals -6.
And 3x equals -6. Again, we set free what was inside the absolute value bars. That stays the same in both of our cases, but on the other side, we have to put the 2 numbers that have the distance of 6. Mara.
Then we divide by 3 on both sides.
Okay, and now we do have to do step C in this one. We do have to solve, so we're going to divide both sides by 3. And we find our solutions are going to be x equals 2 and x equals -2. Okay, now, let me stop you right here before you move on, because you're really pretty confident about this stuff. Like, because I know how 9th graders think with these problems, or your brain is starting to go there possibly. What happens every time in all 3 of these problems, Rita, with the solutions? What's true? What relationship do the 2 solutions we got in a problem have to each other? Justin?
They're all whole numbers.
They're all whole numbers. Well, no, they're not all whole numbers, because the whole number starts at 0, and they go 1, 2, 3, 4. Those are the whole numbers. But what's the name of those numbers when they include the negatives of them too? Okay, so London? They're all real numbers. Yep, they all belong to the real number system. Anybody know what they're called when they're whole numbers and they're opposites? Starts with an I. Starts with an IN. Starts with an INT.
Irrational.
Integers.
What did you say?
Integers.
Integers. They're all integers, but that's not the relationship I was looking for. I want to know what the relationship 2 has to -2. I want to know what the relationship 6 has to -6. I want to know what relationship 9 has to -9. Starts with an O.
They're opposites.
They're opposites of each other. Okay, so here's what might happen when you're solving these. Your brain will be like, oh, seriously, every single time the other solution is the opposite, so why would I go through the work the second time? If I get the first answer, and the first answer is x equals 5, I don't have to do the other case. I can just say the answer is x equals -5. Isn't that what your brain's going to want to do? Okay, do you think you can? Do you think you can shortcut it like that? What do you think? Yeah? Erin says, yeah. Let's do it. Huh. Now she's changed her mind. Huh. What do you think? Do you think we can do that? Because if we can, why not? Let's not go through so much work if we don't have to. All right, every single time we solve an absolute value equation, here's the question on the floor right now. Every single time we solve an absolute value equation, are the 2 solutions going to be opposites?
Yes.
Yes.
Most of the time.
Flip your paper over. R154 184 down there at the bottom page, were those the two solutions we have for that one? Are they opposites?
No.
Oh. Do you think we can just take that chance? No. So we're not done. Okay? Okay. So that's what your brain's gonna wanna do, because already know how teenage brains work. I don't wanna do any more than I have to. And then I don't even wanna do what I'm told to do, but, okay. What are we gonna do in number 4? Do we have to do step A?
Yes.
Yes, okay. What are we gonna do first then? We're gonna do step A. Class, what are we gonna do?
Subtract 5.
Subtract 5 from both sides because this is a multi-step equation, I bet. And we always undo addition or subtraction first, typically because it just makes the problem easier for us. Doesn't mean we have to, but you know what? It sure makes life a lot easier right here at the end. And now what does our equation read? 2 times absolute value x equals 12. Okay. Step A over? Why not?
Because you still have 2 on the outside.
Because we still have that 2 on the outside, so we have to do another step in step A. Now we have to take our left side and divide by 2, and we have to take the right side and divide by 2, so that we can get that absolute value expression isolated. And then we can say we have absolute value of x equals 6. Is step A over?
Yes.
Okay, moving on then. Will you always have to do step B? Always, always, always. There will be, what won't be in step B? What will we never see in step B? The absolute value bars. Okay, so what are the cases I can set up this time? We need to hear from some of the girls here besides London and Kara and Michaela. X equals 6 and x equals -6. And notice the absolute value bars are gone. The expression that was inside of them is now set equal to the 2 numbers that have a distance of 6. Do we need to do step C? No, x is already isolated. Marco.
Okay. When will there be a problem where the answer is going to be not opposites, but the same?
What do you mean the same?
Not a positive and a negative, but
Means not opposites, but I don't know. Maybe you'll discover that as you're solving. You'll be like, hey, it seems like whenever this is the case, this is when I get opposites. And when this is the case, this is when I don't get opposites. Maybe you'll discover that as you when you start working